All right, so this is our second day of factoring. This is 3.2, okay? And we learned basically the basic process yesterday, okay? But there are certain rules and certain special situations that are going to keep coming up. One of those special situations is called difference of squares, okay? Difference means what? Subtraction. So we're subtracting two perfect squares. So a squared minus b squared will always factor into, no, not c squared. This is not Pythagorean theorem. A minus b times a plus b. A squared minus b squared will always factor into a minus b times a plus b. Let's check it in case you don't believe me. Let me show you why this works. Let's go ahead and multiply a minus b times a plus b. So I'm going to have a times a plus b minus b times a plus b. I'm going to get a squared plus ab minus ba minus b squared. What happens to those middle terms? They cancel. A squared minus b squared. So a squared minus b squared will always factor into a minus b times a plus b. Okay? All right, so let's try some examples. X squared minus 25. What squared gives us x squared? Okay, so I have x squared minus. What squared gives me 25? All right, so essentially, x is a and 5 is b. So I've got a squared minus b squared gives me a minus b, x minus 5, times a plus b, x plus 5. All right. Let's factor 169 minus x squared. What squared gives me 169? And I know that x squared gives me x squared. So 13 is a and x is b. So I'm going to have what? Good. You may not switch the order. You cannot, this is not equivalent to x minus 13 times x plus 13. Okay? That is not the same. You have to go in the same order. Okay. 4y squared minus 49. What squared gives us 4y squared? What squared gives us 49? 7. Okay. So 2y is my a, and 7 is my b. So what are we going to get?
2y minus 7 and 2y plus 7.
Good. Could you write 2y plus 7 times 2y minus 7? Yes, that you can rearrange. But you cannot rearrange the order of your terms inside your parentheses. All right, look at number 4. Thoughts? Good. GCF. You have to do with the GCF first. What is our GCF? Okay. So I have 3 times x squared minus 9. Now, can that be factored? Yeah. Now that's a difference of squares. So what happens to that 3 on the outside? Stays on the outside. And what am I left with? X minus 3 times x plus 3. What questions do you have about that? No, you don't have to add any additional brackets because they're all being multiplied together. Any other questions about that? All right, look at 5. 20b squared plus 36. Okay, and what would our greatest common factor be? Yeah? What happens next? Yeah, that's as far as we can go here. Why? Okay, that is one reason. 5 is not a perfect square. There's another, almost more important reason. Blake? Yeah, it's a sum of squares. Okay? We only know a rule for a difference of squares. Okay? So you might want to make yourself a note. A squared plus b squared is completely factored. We don't know a rule for sum of squares. Nope, there is no way to factor that.
Are we supposed to simplify it to factor it out, or should we just write it's completely factored?
You can't simplify it. You're asking if you were given a sum of squares and asked to factor it?
Like, is your answer like 4, like parentheses, blah, 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 or is your answer like it's completely factored?
Oh, your answer to number 5 is 4 times 5b squared plus 9. GCF counts as part of factoring. Okay. In order to make your life easier, you need to memorize perfect squares. Okay? You need to memorize all perfect squares from 1 to 15. You already know most of them. Okay? I will talk more about when you will need to know this by at the end of the lesson. But it's really important that you mark down somewhere you're responsible for memorizing the perfect squares 1 through 15. Okay? All right. Let's talk about cubes now. Let's talk about another rule. Sum of cubes and difference of cubes. Okay? Your rule for sum of cubes, anytime you have a cubed plus b cubed, sorry, my pen is. That factors into a plus b times a squared minus ab plus b squared. A plus b times a squared minus ab plus b squared. Okay? Your rule for difference of cubes is very, very similar. If I have a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared. Those are your rules for factoring sum and difference of cubes. You must memorize these rules. Okay? Factoring sum and difference of cubes is really straightforward as long as you memorize this rule. All right? Let's check one to show that I'm not faking you out. You want to check sum of cubes or difference of cubes? Sum, okay. So let's take the factored form, let's multiply it out and see if we get back to our original. Okay, so if I want to check this, I'm going to go ahead and double distribute. We're just taking the factored form, we're going to multiply it out and prove that we get back to this original. All right, so when we distribute that a, a cubed minus a squared b plus ab squared. Yes? Okay. Plus b times a squared. Would you agree that I could write that as a squared b? Minus ab squared plus b cubed. Everyone okay with that? Look at those middle terms. What happens? Yeah. What's all you're left with? It works. Ta-da! Yep, the same thing happens with difference of cubes. Okay, I want you to look at your formulas. They're extremely similar, right? Notice that the only thing different is your first two signs. The first sign matches the sign you started with. So if you started with plus, you get a plus sign first. If you started with minus, you get a minus sign first. What happens with the second sign? Switches. Okay, it was plus, it goes to minus. It was minus, it goes to plus. And the third sign is always plus. Okay, so to remember this, you can use the word SOAP. S-O-A-P. SOAP. S stands for same. The first sign is the same. O stands for opposite. The next sign is the opposite of the first. And the AP, what do you think that stands for? Always positive. Same sign, opposite sign, always positive. Well, I guess a plus would work too. I thought you were saying A plus, like, you did great. But yes, A plus sign would work fine too. Okay? So use this to help you out. It's a really, really great memorization tool. All right, let's work a couple. X cubed plus 64. So let's figure out what cubed gives us x cubed. Okay. Plus what cubed gives us 64? 4. 8 squared gives you 64. I want cubed. Yep. Okay, so let's go through this. Start with A. What's A? Yep, A is x and B is 4. So A is x, same sign. What's my sign? Plus, what's B? 4. Times A squared, what's that? Opposite sign, minus AB, 4x. Always positive means plus B squared, 16. Questions on where any of that came from? That's your factored form. Yep. Well, sum or difference of cubes is never going to factor further. You're going to stop right there. Okay? All right, let's look at 7. 27 plus 8x cubed. What cubed gives me 27? What cubed gives me 8x cubed? 2x. All right, so A is 3 and B is 2x. All right, A is 3, same sign, plus B is 2x. A squared, what is 3 squared? 9. Opposite sign, minus A times B, 6x. Always positive is plus, and then B squared. What is 2x squared? 4x squared.
Wouldn't you put the x squared in parentheses?
Nope. Okay, if you square 2x, it's multiplication, so you distribute your squared. 2 squared is 2, x squared. Or sorry, 2 squared is 4 times x squared. Okay, look at 8. 125. What cubed gives us 125? And what cubed gives us x cubed? All right, please go ahead and finish number 8. All right, tell me what we get. 5 minus x, good. Okay, wait. Don't put 5 squared. We know what that is. 25. Okay, then what? Plus x squared. Yeah, let's talk about 9. 343, what cubed gives me 343? 7. So this is 7x cubed minus, what cubed gives me 1? 1. Ones can be tricky, but they are both perfect squares and perfect cubes. So make sure you remember that. Jason, do you have a question? I'm going to tell you which ones. I'm going to tell you which ones in just a second. All right, what'd you get? 7x minus 1 times 49x squared plus 7x plus 1. Great job. Do you see how it's not that hard if you memorize the rule? If you memorize the rule, you're going to be fine. Okay, but in order to know when to use the rule, you have to know what are perfect cubes. Okay, so you also need to memorize perfect cubes 1 through 10. You need to also memorize the perfect cubes 1 through 10. So here's how this will show up. On Friday, when it's about time for your quiz, okay, I'll first pass out one sheet. After everyone has it, you'll flip it over. You'll have 90 seconds to complete the perfect squares and the perfect cubes, okay? They will be jumbled up a little bit, not factoring, just recognition, okay? They'll be jumbled up, but they will be separate. Squares in one column, cubes in another column, okay? No, it's not matching. You just fill in the blank, okay? So memorize with flashcards. Do 1 through 15 squares, 1 through 10 cubes, okay? But make sure that you don't only practice them in order, okay? You've got to mix them up because I'm not going to give them to you in order, all right? 90 seconds is more than enough time as long as you're not sitting there trying to multiply out what's 7 cubed, okay? If you're trying to multiply it out, 49 times 7, you're going to run out of time. But if you know them, if you walk in here knowing them, you're going to be totally fine. We're not making you do this as like extra work, but as you can see, if you don't recognize that one of these is a cube, you're not going to know when to use your rule, right? If you don't recognize the squares, you're not going to know when to do it. So we're just trying to save you some time. Okay, question?
When you say perfect cube, do you mean like one cube?
Any other questions? Okay.